well logs were utilized in the construction of the geological model in your presentation. Definitely, the slide number 12 is not. So I just want to be sure that we do have that information that were utilized to be able to build the geological model. Um,
I, I can get you that answer.
okay, I appreciate
Definitely.
that. Let's go to slide number 16. Now, the faults that you picked, at least you've shown us the fault slip analysis that was done. But let me ask, in the hydrodynamic simulation itself, how did you handle the fault? In the simulation itself, how did you handle the faults?
In what way? They were an input to the simulation. Well, I'm sorry, I don't understand that question.
Okay, let me help a little bit. So you have the fault, and okay, then let me put it this way. Is this fault closed or open faults?
Oh, I see the question. How did we input it in the simulation? If it's
Yes.
closed or open faults? I believe we have them. I have to give you the correct answer, but I believe we treat them as open faults. But I will give you the correct answer during the break.
I will need that answer, and then I want to know the justification as to how you chose whether it's a closed or open. So normally you don't have the data, for this unless you drill through. So normally you have two scenarios where one will be open and then one will be closed to show the commission that even if it is open or closed, maybe I'm still able to put in the volume, the required volume. So I want to know, is it open or sealed faults? And what is the justification for that? How were you able to do that or come up with that number, especially when you didn't do the sensitivity analysis? The force slip analysis is good, but the simulation itself, where you get the information to put into the force slip analysis also has to be correct as well. So yeah, if you can provide that information, that would be wonderful.
Yes, definitely, I will.
And you're saying that these faults will not have any impact. I've seen the pressures, you've done the force slip analysis, the amount of pressure buildup that needs to cause any potential, let's say, reactivation of these faults, depend on how you put it. But this fault is going all the way past the bonnet. So what about brine migration? You are pushing the brine away from the injection well. So what about brine migration?
Yes, I don't think the brine will reach that point based on our analysis. And I see your concern about maybe potential leakage, but based on our analysis, I don't think we will reach that point.
I will probably disagree on that. I mean, you have a fault that is, so the same slide that is on. You have less than a mile away from, let's say, the fault, less than a mile away from the fault. So I don't know how magic you can do it in such a way that 45% of the space that will be available to contain the CO2, you are not going to have impact. You're not going to displace the brine to that particular fault. If you look at the volume of your CO2, what is the footprint? You have it somewhere. The total distance for the plume was 1.04 miles of tag plume. And assuming those miles is more or less moving to the south, that is like 33 or 34. How is it? I mean, definitely there is going to be a brine migration. So maybe something to look into. And then also for NMOCD as well, especially when they are coming back, let's say after 5 years to give an update. So something for us to keep an eye on. How was the fracture pressure calculated?
Fracture pressure, how it's calculated?
Yeah, how was it calculated in your model? Or let's say, what is the source of that information?
We use the depth multiplied by 0.65 psi per foot.
So the 0.65 is the one that I'm talking
Yes.
about. How was it? How did you come up with that number?
That is, I believe that's from the regional, and that's what we had penned from the literature.
So then that goes to the fact that once the well is drilled, you're going to do a separate test. So definitely you're going to have your actual number, and that would determine whether you get 26 million standard cubic feet of injection or not. So I think we can take it that we can take it like that. That is good enough.
Yeah.
Now on your slide 24, on your slide number 24, I'll be very brief. So now when I look at these parameters, slide number 24. Yeah. When I look at these parameters, so you've highlighted your cap rock and then the reservoir zone. I mean, you have a cap rock with a porosity of like 1%, 1.5%, and your actual injection zone have a porosity of like 2%. So I'm wondering, is it really a cap rock? And I'll be surprised. I'll be surprised to see that comparison, how your plume did not really move up the cap rock. So can you respond to how you look at the differences between the properties for your cap rock that you use for the modeling, and then tell me how you feel like, let's say, just between a difference of 1.2 becomes a reservoir, or let's say a cap rock.
Okay, so based on our analysis, the maximum porosity in our injection zone is about at 10%. The primary porosity comes from the limestone. The secondary porosity, where we believe is from what our analysis is Pritchard zone, right? And that's where secondary porosity comes from. And we believe it's much higher than of course than the cap rock. And you have also secondary cap rock on the top over there that actually guarantees that there is no leakage going to be there. But yeah, I see your point here.
So how did we? Definitely, we do know that Woodford Shale is a shale, so definitely is a good cap rock. Right. But I'm wondering the type of porosity and then the permeability that you are showing here. Really. I mean, I can guarantee you that if you do a modeling with a cap rock of 0.1 millidarcy, you're going to have CO2 moving. So I don't know whether you guys had that situation or not.
Okay, I think I have an answer for you on this. Okay, so the porosity that you see in the cap rock is what's called microporosity. This actually, because it looks higher than it is, because it's water bound to the formation, and that's why your porosity shows much higher here. But this is actual microporosity in the cap rock.
Let me ask about the salinity. So you had 3 wells that you collected data from. So 3 wells within 11 miles. So does this well more or less go through your injection zone?
Yes.
It goes through your injection zone?
Those wells, I believe so. I need to confirm that, but I believe so.
Okay. The pressure.
And we average them out, as you see.
Yeah, so I think I do have some outstanding questions that probably, if you can concur with your team and probably respond to that later. One is how many wells that were used for the property modeling? how the fault was modeled within the model. Is it a closed or open fault? And since you didn't do uncertainty analysis on that, how did you come up with, let's say, whether it's closed or open? And the fault transmissibility. Yeah. So what fault transmissibility was used in the simulation model?
Okay.
Now let's talk about the temperature issue. The temperature issue. So you said how did you calculate the temperature though?
This is from the literature.
Yeah, when you say from the literature, what was from the literature though? Like what was the information you got from the literature?
We looked at in the regional area, and we decided that 2225 was an acceptable value in this area. But I can also confirm if we use any other wells from that area.
So definitely then you are looking at the temperature gradient. You got the temperature gradient from the literature,
Right.
and then you try to use that to back calculate what is the ultimate temperature within your zone. Now, a question was asked, how is that temperature changing when you are putting in the CO2? Did you look at the potential temperature changes? You know, how it impacts your wellbore? I think that was a question that was asked.
Okay.
And hopefully you can concur and then come back and tell us, you know, with regards to, let's say, how the temperature is going to change over time. And does it have any impact on the, let's say, the wellbore or not? I think that was the question that was asked. And I'm interested in that too. So,
Okay. I'll look into that.
but I'm going to stop here. Thank you.
Could I recommend a lunch break? Just considering that for time, we still have, they want to concur with each other about some things, and we have a witness as well.
I was going to recommend a lunch break. I was just waiting for the doctor to finish his questions. So yeah, why don't we take, if everybody's okay with that, let's take an hour lunch, and we'll be back here at 1:45.
Thank you.
Can I leave now?
Okay. So I guess he's not excused, right? He'll come back. Okay. Okay. Yes.
Okay.
Then we'll ask more questions. Okay. Okay. Thank you. Okay.